Hello everyone, and welcome back to Insight to Invest, the channel that gives you insight into a company and you decide if you want to invest for the long term to grow your money. Today, we're diving deep into a company you might not have heard of, but one that is absolutely essential to the modern technological world. Cadence Design Systems. Let's jump into it. If you're into tech, you've probably heard of Intel, NVIDIA, Apple, Samsung. But have you ever wondered how those companies actually design their incredible complex chips, the circuit boards, and even entire electronic systems? That's where Cadence comes in. They are one of the unsung heroes of the semiconductor industry, providing the tools and intellectual property that engineers use to bring our digital future to life. Think about it. Every smartphone, every laptop, every smart device, every piece of advanced medical equipment, and every autonomous vehicle relies on incredibly sophisticated electronics. These aren't just designed by hand with a pencil and a paper anymore. They require highly specialized software, electronic design automation, or EDA tools. And that, my friends, is Cadence bread and butter. Let's take a quick trip back in time. Cadence Design Systems was formed in 1988 through the merger of two companies, SDA Systems and ECAD. Both were pioneers in the nascent EDA industry. Their vision was to create a comprehensive suite of tools that could handle the entire electronic design process, from conceptualization all the way to manufacturing. Fast forward to today, and Cadence is a global powerhouse. They're headquartered in San Jose, California, right in the heart of Silicon Valley, and they have offices all over the world. They employ thousands of brilliant engineers and scientists, all working to push the boundaries of what's possible in electronic design. Now, what exactly do they do? Cadence's product portfolio is vast, but it can broadly be broken down into a few key areas. First, and perhaps most famously, is their EDA software. This is the core of their business. They offer a list of tools like chip design, system on a chip, and verification. Let's break down each one of those one by one. Chip design. This includes everything from digital design and verification to analog and mixed signal design. Their tools help engineers create the tiny transistors and complex logic gates that make up microprocessors, memory chips, and more. System on a chip design. Modern chips are often entire systems on a single piece of silicon. Cadence provides tools to integrate processors, memory, and specialized accelerators all onto one chip. System, interconnect, and packaging. How do you connect all these components together, both on the chip and in the final product? Cadence has solutions for high-speed interconnections and advanced packaging technologies. And last, verification. This is absolutely critical. Imagine designing a chip with billions of transistors. How do you ensure it works perfectly before you spend millions of dollars manufacturing it? Cadence offers incredibly sophisticated simulation, emulation, and formal verification tools to catch bugs early. Beyond just software, Cadence is also a major player in intellectual property, or IP. What's IP in this context? Pre-designed, pre-verified blocks of circuitry that engineers can drop into their chip designs. Think of it like Lego bricks for chip design. Instead of designing a USB controller or a Tensilica DSP from scratch every time, companies can license IP from Cadence and integrate it into their own custom chips. This saves immense amounts of time and money and allows companies to focus on their unique innovations. Cadence's Tensilica digital signal processor, or DSPs, for example, are widely used in a variety of applications, from audio processing, smartphones, to AI acceleration and edge devices. Their memory IP and interface IP are also crucial for many designs. And finally, a rapidly growing area for Cadence is system analysis and simulation. As electronics become more complex and integrated into larger systems, like an entire automobile or a 5G base station, is not enough to just design the chip. You need to understand how it behaves in the real world. Cadence provides tools to analyze signal integrity, power integrity, thermal performance, electromagnetic interference, or EMI, and even multi-physics simulations. This ensures the entire system works reliably and efficiently. So, you can see how comprehensive their offerings are. Cadence essentially provides the entire toolkit for modern electronic design. The semiconductor industry moves at an incredibly fast pace. Cadence invests heavily in R&D to stay ahead of the curve, constantly developing new tools and methodologies to address the challenges of shrinking geometries, increasing complexity, and new computing paradigms like AI and quantum computing. Along with their main competitor, Synopsys, Cadence forms a duopoly in the EDA market. This isn't necessarily a bad thing. It means these two companies are constantly pushing each other to innovate, and their tools are the industry standard. Nearly every major semiconductor company in the world relies on Cadence tools. As chips get smaller and more powerful, new challenges emerge: power consumption, heat dissipation, manufacturability, and the sheer cost of development. Cadence's tools help engineers optimize for these factors, enabling the creation of more efficient and sustainable electronics. We're moving beyond single monolithic chips. Modern systems often integrate different types of chips: CPUs, GPUs, memory, and custom accelerators, often from different foundries, into a single package. Cadence is at the forefront of providing solutions for this heterogeneous integration, making it possible to create these incredibly powerful multi-chip systems.
Once aligned, the chiplets snap into place, enabling high-speed data transfer across the unified package.
So what does the future hold for Cadence Design Systems? I see a few key trends that will continue to drive their growth, specifically in 4 key areas. Number 1, AI machine learning. Number 2, the metaverse and digital twins. Number 3, automotive and industrial Internet of Things. And number 4, cloud-based EDA, or electronic design automation. So let's go over them one by one, starting with AI and machine learning. AI isn't just a workload for chips, it's also a powerful tool for designing chips. Cadence is heavily investing in using AI within their EDA tools to automate tasks, optimize designs, and speed up verification. This could revolutionize the design process. Number 2, the metaverse and digital twins. As we move towards more immersive digital experiences, the need for hyper-realistic and efficient hardware will only grow. Cadence tools will be crucial for designing the chips that power these future realities. The concept of digital twins, creating virtual models of physical systems, also relies heavily on advanced simulation, an area where Cadence excels. Number 3, automotive and industrial Internet of Things. The industrial Internet of Things is connecting everything from factories to smart cities. Both sectors demand extremely reliable, power-efficient, and secure areas where Cadence tools are indispensable. Number 4, cloud-based electronic design automation, or EDA. The ability to run massive simulations and design flows in the cloud offers immense flexibility and scalability. Cadence is actively moving its offerings to support cloud-based workflows, making their tools more accessible and powerful. In conclusion, Cadence Design Systems might not be a household name, but they are an absolutely critical enabler of the digital age. Every time you pick up your phone, use your computer, or interact with any piece of advanced electronics, you are indirectly benefiting from the tools and innovation that Cadence provides. They are the quiet giants behind the scenes, empowering engineers to push the boundaries of technology and create the incredible devices that shape the world. That's all for today's deep dive. What other hidden tech companies would you like me to explore? Let me know in the comments below. Don't forget to like this video, subscribe to the channel, and hit the notification bell so you don't miss the next episode. Thanks for watching. I'll see you in the next one. Bye.